Alrighty, so let's talk about the first day of 2.1. So this is about relations and functions. So to start off, a relation is any set of ordered pairs. It could also be listed or expressed as a list / set, a table, mapping diagram, a discrete graph or non-discrete graph, or an equation. So pretty much anything that you can graph is considered a relation. So if you see, like they say, write the data as a list or a set, you just write it as an ordered pair. So like this is just a made up one. 4, 2, -3, 6, 2, -1, and 0, 2. Okay, so that is a list or set. Another way to write it is as a table / chart, whatever you want to call it, same thing. So you would just write 4, 2, -3, 6, 2, -1, 0, 2. Okay. A mapping diagram. So this one's different. You've seen those other two. This one is different. It's kind of fun. Something I can definitely see on the ACT, so it's good that you know how to read one. So it has like two ovals, and then you have to put the numbers in order. So numbers in order on this one has to be. So looks like we've got -3 for the x's. Then 0, then 2, then 4, and then I have -1. I'm only going to write 2 once. You don't write it twice. And then 6. Okay, so now here's where the fun part happens. You just get to kind of connect them. So that first point, 4, 2, would be, you would do it like this. -3, 6 would be right there. 2, -1, 0, 2. As you notice, 2 has two lines on it. That's okay. You can do it like that. It is perfectly fine. That's actually how you do it. Okay, so if you notice, those three things, the list, the table, and the mapping diagram, all represent the same data. So those are just different ways to do it. So just know they all mean the same thing. They're just a bunch of ordered pairs. So another way to, an example of a relation is just a graph. So just something like this, a line, it could be a parabola, it could be a lot of things. And then the last one we're going to talk about is an equation, for example, like y equals 2x minus 4, or something like that. Okay, so now let's get into the fun part. So the blank of a relation / function is the list of all possible inputs. You need to have this memorized because this is going to come up a million times in this class. So domain. So just remember, domain is your x values. Always, 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 always. And then the opposite of domain is range. Okay, so range is the list of all possible outputs, aka the y values. So just remember, domain is x's, range is y's. Okay, if a graph is discrete, give your answers as a list. So a discrete graph looks something like this. It's just a bunch of coordinates. Okay, that's all. Okay, discrete means just a bunch of dots, discrete dots. Okay, then so the opposite of discrete would be a continuous graph. So a non-discrete or continuous. I think I spelled that right, but it's okay. So an example of a continuous graph would be something like this, or it could be a line, or whatever. It's anything that you don't have to pick your pencil up whenever you're drawing it. Okay, so for the next little section example, I think there's a few homework problems like this. Describe it as the following as discrete or continuous. Well, that first one is going to be continuous, right? Whenever you draw a circle, you don't pick up your pencil, so that's continuous. That next one is definitely discrete, right? And then the last one, C, would be continuous as well. Okay? All right, so now let's get into, you have a lot of questions like this. Is it a function? So a function is a relation where each input has exactly one output. AKA, this is something before actually we go into it, let me tell you what the easiest way to see is. This is my favorite way, is to use what's called the vertical line test. So let me draw a graph. Oops. Okay, and it's better if you see this in person. It's a little bit easier to see, but we're going to do our best. So if I draw a graph, like something like that, it doesn't matter. And if there's any point where I can draw a vertical line and it will hit 2 points, so say I'm going to just keep drawing vertical lines. And notice, every time I draw a vertical line, it never hits that blue line more than once, okay? So if it doesn't hit it, that means this is a function, okay? Let me draw another one that is not a function. So if I had something like this, and I had a graph that was kind of like this or something crazy. If you drew vertical lines, you see there's like multiple spots where it hits. So when that happens, that means this is not a function. Okay, and it really only has to do it once. Okay, so just know if it hits multiple places at least once, then automatically not a function. Okay, so one last thing. They're also going to give you a graph, or not a graph, a table, or maybe a list of points like you're about to see. The shortcut way is you don't have any repeating x's. So yeah, the x's don't repeat. If the y's repeat, that's okay. And I'm going to show you what that looks like. If you remember that shortcut right there, it'll make your life easier. But if not, you can always just sketch a quick graph. Okay, so domain is and range. We have to list the domain and range and tell me if it's a function. So this is a mapping diagram, which remember is just a bunch of ordered pairs, so coordinates. So domain is always your x value. I'm not going to write this every time, just this time. So x and y, always domain is x. So and it even tells you the domain on this one. This one's kind of a cheat. So you're literally going to write 2, 3, 4, 6. And then the range, you're just going to list them out. They have 4 of them. -3, -1, 3, and 6. Okay, you just did, that's a discrete relation, so that's how you list them, is a list, okay? Is it a function? So some of you may already see that it is not a function because this x right here, 2, repeats. There's 2 coordinates that have an x value of 2. If you weren't sure, let me sketch a quick little graph of what this looks like. So 2, -3 would be about right there. 3, -1 would be about right there. 4, 3 would be about right there. 6, 6 would be about right there. And then I forgot the other one. 2, 3 would be about right there. Okay, so as you can see, these right here, my graph's not perfect, but as you can see, those 2 dots would not pass the vertical line test. So that's why I say if you have the same x, like the 2 points have the same x coordinate, they're not going to pass the vertical line test. If you forget that trick, that the x's can't repeat, that's okay. Just sketch a quick graph like I did. It takes 10 seconds. So is this a function? No. Okay, here's another one. It's a list of points this time. So since it's a list of points, this is going to be a discrete graph, which means it's just a bunch of points. So list the domain. The order does not matter. So list the x values. We've got 0, -2, 2, 3, and -3. And let's list the y values for the range. 0, 4. You don't need to write 4 twice on this one, or 9 technically. You can if you want to, like on a test or a quiz. I wouldn't count it wrong. It's just kind of a wasted step, okay? And so is this a function? Well, I'm going to graph it. Well, first let's try to look at it. Do any of the x values repeat? The answer is no. So since none of the x values repeat, it is a function. I know this is weird, so let me just sketch a quick graph. So we've got 0, 0, negative 2 4s, 2 4, 3 9, negative 3 9. So as you notice, this passes the vertical line test. Sorry, my vertical lines are looking a little sketchy. Okay, so that's what I mean by is it a function? Yes. Okay, this one, let's just get the easy one out of the way. Is this a function? Looks like it to me. It passes the vertical line test, so this would be a yes. This is a little different. Okay, so if you were here for the interval notation notes, you'll get this. I don't have that video recorded, so I'm going to go slow on this. So this line is going forever this way and forever this way, right? Like it forever. So remember, domain is the x values. So what is the smallest x value? So the one to the farthest left point that this is going to be. Well, it's kind of an abstract idea because it goes on forever in that direction. So you can never like actually put a number on it. It goes to, how we say it is, it goes from negative infinity, because that's the smallest number that you can write. I can't like put a numerical value again because I could just go a little bit smaller. So negative infinity is the lower bound, is what it's called, the smallest domain. And since it goes all the way to the right, since that goes on forever to the right, the upper bound would be positive infinity. Okay? And so whenever you write this, you have to write what's called interval notation. You put a comma in it. So if you might remember from inequalities and graphing those, you use either brackets or parentheses. So brackets are when they actually hit that point. Parentheses are when they approach that point. So on this, and I'll say it again, brackets when they hit the point, parentheses are when they approach that point. So do they ever hit negative infinity or infinity? The answer is no, because you can never hit it, because it keeps going on forever. So in that case, we must put parentheses on there. Okay, now let's talk about the range, which is the y values. So you always, whenever you're writing this interval notation, you must put the smaller number on the left. If you don't, it's wrong. Okay, so let's talk about the bottom. What's the smallest number? Well, that one goes all the way down on the y-axis, goes all the way down to negative infinity as well. Okay, and then it goes all the way up. That graph's going to keep going up forever, so it's going to be negative infinity to positive infinity as well. I know this is weird. Just keep practicing. I promise. Just trust me. Okay, next one. This is the graph of the absolute value of x. Pretty soon we're going to be graphing this in the next unit, actually. So get ready. It's fun. Anyway, so the domain, the x values. So let's talk about this graph. It looks like it starts right here. The bottom part of the graph is there, and then it goes on forever this way and this way, right? Okay, domain. Domain is your x's, so this way and this way. What is the farthest left you're going to go on this graph? Well, this is another one of those negative infinity ones, right? Because this is going to keep going left forever. So the lower bound would be negative infinity, and it also keeps going right forever. So that would be positive infinity. Okay, it's not always going to be like that, so just wait. All right, this is where it does get different. The range. So range is your y value. What is the lower bound on the range? Well, okay. So this one does not go down forever. There is a minimum point, right? The minimum point is right here. What is that y value? It is 0. Actually, I should erase this. The minimum point is 0 on the y-axis. What is the maximum point? Well, this keeps going up to infinity, so that's going to be infinity. We know that has to have a parenthesis. If you notice, I erased that other parenthesis, and let me tell you why. Because remember I said it's a bracket if it hits that point, and it's a parenthesis if it approaches. That actually hits that point. So it does reach 0, so therefore we must put a bracket. Is this one a function? Yes. Okay, the next one, domain and range. So this is a circle. It looks kind of crazy, right? Okay, you're all right. So domain, the x value. What is my smallest x value on this? Looks like it's right there. So that would be -4. Does it hit -4 or does it approach it? So unless there is an open dot, it looks something like that, but prettier. Unless there's an open dot, just assume that it hits it, and you'll know very clearly if it's an open dot or not. So since there's no open dot, we're going to have to put a bracket because we assume that it hits -4, which this one does. Okay, and then what's the upper bound for my x values? Well, that would be right there. So that would be +4, right? Okay, the range, what's my lower bound for my range? Well, that looks like -4 as well, and it does hit it, so I'm going to put a bracket. And then my upper bound is +4. Is this a function? Yes, it is. Okay, that is it for this lesson. Let me know if you have any questions, and I hope you have a great rest of your day.